In this video, I will apply the observer pattern, that is the original one I introduced in the previous video. I have the same code example with the temperature sensor, which needs to notify various interested classes. I just renamed the sensor class for clarity here. I will start with a package for the new stuff we are about to add. It will be called observer tooling, for lack of better naming. Then I do the interface first, that's easier. I create a new one, calling it listener. There should be a single method, let's call it notify. The parameter is of type object. This allows us to reuse the interface in other settings. Then the abstract class called subject, and I forgot to make it abstract, but anyway. It needs a list of listeners. There must be a public method to add a listener, and a public method to remove a listener. And then the protected method called notify listeners. It of course declares an object parameter. The job of the method is to just iterate over all the listeners in the list, and for each of them call the notify method passing along the argument. Great, that's the observer tooling in place, now we can apply it. Let's start with a concrete subject, which is the temperature sensor class. This class simply extends from the subject to inherit the functionality. And in the method where the data changes, I can now call the protected notify listeners method from the subject class. I pass along the newly measured temperature as the argument here. Now let's fix one of the listeners. I will start with the UI class. It must now implement the listener interface, which then requires me to override the method. Here I receive an object, but I know it's actually an integer, so I can cast it. I then convert it to a string and call the setText method. Done. Let's just fix the other two classes in a similar manner. First, the sensor alert class here. Implement the interface. Override the notify method. Cast the object to an int. And call the receive sensor data method. And the last class, sensor log. Again, implement the interface. Override the method. Cast the object argument to an int. And call the log method. Now everything is mostly ready. I just need to actually tie things together. I have not yet added listeners to the subject. We have two approaches. Either a listener class gets a subject through its constructor and adds itself. It would look like this. Alternatively, this is handled elsewhere. In my case, that could be the start method, and that is my preferred approach. So let me just undo the constructor stuff here and find the start method. And here I have the sensor first. The UI class is already created. I just need the sensor log class created, and then the last one, sensor alert. Now I can add all three as listeners to the sensor. And again, this is my preferred approach, tying everything together outside of the subject and listeners. It lets the listener class remain ignorant of the subject class, loosening the coupling a bit. It may not always be the best approach, but it is my default. There may be situations where it is better that the listener class actually knows about the subject, maybe so that it can remove itself if necessary. But let's just run things here. And the UI is updated, and the alert seems to work many times. And let's just check the file. Plenty of output. So things are tied together correctly. My observer pattern is in place. Now, a few comments. First, Java actually has an existing abstract class called observable. It is, however, deprecated, and we should not use it anymore. I will show the newer Java alternative in the next video. They have some other tooling now. And to match the observable class, Java has an observer interface. But again, these are deprecated, don't use them. And this also implies my own implementation here, which is very similar to the deprecated Java one, is not all that great. So let's look at a problem. I have another sensor. It measures wind speed as an integer. I could make this observable by extending the subject and notifying the listeners down here. And then, for example, in the sensor log, I might be interested in logging both temperature and wind speed. But I just have the notify method, one of them. Both subjects will call this. How does my sensor log know what data it receives? The type is even the same from both subjects, so I can't distinguish based on that. Sometimes it's a temperature and sometimes it's wind speed. So to fix this, I could update my pattern implementation. Instead of sending an object, I send some container class with extra information. I can create a subject event class here, or I will just use a record. That's simpler. The first parameter is the name of the event, for example, temperature or wind speed. The second is the actual data. I will then update the subject class to use this event record. I need to update the subclass, the temperature sensor. It now sends a subject event object instead. The listener interface must be updated too, which causes an update in each of the listener classes. Let me just fix the sensor log first. Now I can at least switch on the subject event type and react accordingly. This basically solves my problem. My listener classes can now listen to events from many subjects, or multiple events from one subject, if necessary. I can expand my weather station with a wind direction sensor too, and in the sensor log class I just need to add more cases to my switch. But each of the other listener classes must also be updated, one way or another. Let's take the sensor alert. This one is only interested in temperature events. What if the temperature sensor could fire other types of events, like humidity? Sure, that might be better to create a separate class for that, but for now, just play along. One class can fire different kinds of events. So I have to check the event type. That's not too bad. But still, the sensor alert is notified about all events, even though it is only interested in some of them. Therefore, it has to do some filtering. And this annoys me. Each time a new event type is added to my subject, I potentially have to update listeners to handle or ignore this event. And it is always the same notify method I have to touch. I prefer that whenever new functionality is required, I do not need to touch existing code, I only need to add new code. This problem is covered in the next video about the property chain subject, which will fix it, to some extent, by using Java's new approach to the observer pattern. And then the follow-up video with lambda expressions will show further improvements. So for now, thank you for watching.